Max-Planck Institute for Informatics, a data set of comprehensive DNS resolutions.
All right, hello everyone. Thank you for being here. Today I want to present to you a data set of comprehensive DNS resolutions, which is a data set that we have gathered recently, and due to the 5-minute time constraints, I can of course not go into too much details. However, maybe I can interest you in this data set and convince you that this is maybe useful data. So to answer the question first, what do we mean when we say comprehensive DNS resolutions? Let's have a look at one possible DNS resolution of the example.com zone. And here we see the involved zones in this resolution in the circles, and we see in the squares the name servers that are involved. And we see that we are able to resolve this example.com zone visiting around 5 zones and asking 3 name servers for several questions, right? However, this is but one possible resolution, and there's actually a lot of different ways to come to this result and to resolve some record in this zone. And if we plot all the name servers in zones that are potentially involved, then we end up with something like this. And you can see that this is already much more difficult. And you can also nicely see that there's this whole subgraph to the right here around clustering around.org, which is basically only needed if you decide to use the name server of example.com that is hosted under icon.org. So this is to show that there exists a lot of potential resolution paths, and you never quite know upfront which path the resolver might take. This is up to the resolver implementation and also due to factors like the response time of the individual authoritatives. To make matters worse, there is a lot of complexity involved with different misconfigurations or non-standard behaviors that make this resolution even more complex. However, even if you do these resolutions, the resolver picks one path through this graph and might encounter problems that are only existing on a single path, for example, only due to a single authoritative that might respond different to the others. And in this context, we set out to gather as many of these comprehensive resolutions as possible, and we do so for 812 million domains, which takes us around 89 billion queries, gathering 39 terabytes of data for various resource records. Of course, we do full dual stack data collection, so we ask for IPv4 and IPv6 records, and also ask all the name servers on IPv4 and IPv6. And in general, we just try to capture as many of these incompliances and non-standard behaviors as possible, even though it's of course not possible to capture all of them. What can we use this for? Well, first of all, we would really like to open source this data to also give others the benefit of having a look at this, and also the open source the toolchain that we use to collect this data. What we've done so far, to give you some ideas, and you don't need to look into this graphs into detail, but you can talk to me after the talk if you like. What we've done so far is we looked at IPv6 only resolution problems, which basically are problems that only occur if your resolver is doing IPv6 only, because sometimes if your resolver is doing dual stack, this is overshadowing certain problems because the resolver is able to do an IPv fallback on the way to resolving some name. We've also had a look at inconsistencies and how they can amplify deeper in the tree. For example, if you have inconsistencies in the delegation where the parent name servers give you a different set of NS servers for the child zone than which is being served at the zone apex, then these might overshadow the effects on the child, or they might amplify certain effects. And we have a lot of ideas what we can do next. For example, we could have a look at how these inconsistencies have an effect on DNS-SEC validation, or also on the recent RFC of DNS-SEC bootstrapping, where it's actually required by RFC to have consistent records served. There's also the issue of eDNS buffer sizes, which might cause strange behavior if you have different authoritatives that are using different buffer sizes. Or we could also have a look at IP address level redundancy, where basically you have a lot of name servers in a zone, which in the end all resolve to the same IP, and if this is not an anycast IP, might lead to suboptimal redundancy in the zone. And this is also the point where I would like to engage you. So if you have any ideas what this data can be useful for, what you would like to know, what is maybe of operational relevance, then I would be very happy if you can reach out to me after the talk and we can discuss. Thank you very much.